All right, let's talk about web development. All right, so first of all, what is the internet? Right, so it's a little bit of history. So as we all know, right, the internet is just a huge network of networks, right? So this meta network that spans the world. It was perhaps never meant to be what it eventually became and what it is today. It used to be just a mechanism to survive World War III. We looked at why did we were able to defeat the Germans, and we came to the conclusion that we just bombed the heck out of them, and they couldn't move around, they couldn't communicate, and we certainly didn't want that happening to us. And so we looked at researching ways that we could create a highly redundant telecommunication system that would allow us to, have no single point of failure, right? That would allow us to still keep communicating amongst ourselves and coordinate a resistance. Eventually, this got expanded to include all sorts of research universities and eventually, commercial as well. Although nobody really knew what to do with it, but certainly commerce has a way of finding all sorts of creative ways of using anything, as long as we can make money out of it. So anyway, this is expanded way beyond anybody's dream, but it really took off when Tim Berners-Lee, in the 90s, he was looking for ways of sharing his research papers with his colleagues, of easily formatting their research papers and linking them together with other research papers. Before Tim Berners-Lee, there were a whole bunch of a plethora of mechanisms, small, isolated, disjoint mechanisms that would allow you to, connect through the internet, through all these connected computers, go fetch some content, download it perhaps locally, and use a different viewer, compile it maybe, use a viewer to view the content, and then for human consumption. Yes, and it was very awkward. It worked. It just wasn't very efficient. And he had the idea to, hey, how about we standardize a couple of things here, and marry several of these technologies together to work together, right? Marry the mechanism of retrieving it, and interpreting it and rendering and consuming it and then linking it together with other content. So he developed all the technology for for serving content, for retrieving content, parsing it, rendering it, and then linking it between the different content. So he pretty much, what it did is lower the bar of entry of being able to share information across the web, and it exploded in beyond his dreams, across all sorts of different research institutions, universities, and eventually commercial. He developed the technology of browsers, where he married the two ideas of retrieving the data, compiling it, interpreting it, and then rendering it into a very, very simple piece of software that remove the awkwardness of having to use all these disjoint tools. Some meaningful milestones in the 60s. We have the research and development of the internet as a way of surviving World War III. We developed certain very robust architectures that are still in vogue today. The client-server architecture is still the main way that we think about the interaction between client and servers. It's been around for half a century, and it's still running strong. And up to that point, the main way that we thought about computation was to have these large computers in these centralized rooms, and we have all these dumb terminals around that sent some of the computation to be done, executed on the central server, and then sent back to those dumb terminals, right? With the advent of personal computers, we started to see more and more folks be able to run their applications locally on their personal machines, on their own desktops, right, as opposed to running it on a centralized machine and then seeing only the result. So with the advent of much cheaper hardware and software, everybody could now afford to have some powerful machine on their desktop. Tim Berners-Lee comes up with the World Wide Web, revolutionizes this, and all the tons and tons of software, .com startups, promise all sorts of things on what the World Wide Web is going to solve. Crashes precipitously, although leaving a nice trail of technology that are still with us, right? So a lot of the technology that was developed before the .com bust is still with us, right? But certainly applied to something that is more realistic to commercially and financially. Up to, all the way through the 1990s, we developed a lot of those technologies, and finally in the 2000s, we finally formally consider the web as a platform where we can actually build applications. Right? We start seeing a lot of the desktop applications start to move towards being hosted online. First with simple word processors, blogs, sharing some content online, and now pretty much any application has an equivalent or has some form through implemented on the web, right? Spreadsheets and sharing all sorts of videos and movies and whatnot, right? And photos. So once we identify the web as a platform for development, right, all sorts of frameworks start to appear, right, on the server side and on the front end side, that allow us to build these increasingly complex types of applications. Over time, in the next decade, we have the mobile computing and big data being captured, from folks trying to identify relationships between folks and patterns and purchasing patterns and whatnot, and certainly this affects as well the new audience or the new types of applications that we're trying to build, that can run not only on large screens but also on smaller screens on mobile computing devices. Where we're going in the next decades, who knows? Elon Musk wants to plug us into the phone through his Neuralink. We'll see if that works. So I guess no screens anymore. I don't know. Along the way, this is some of the trailblazing number of frameworks that evolved over time over this several decades. With as a commercial folks try to look for applications of using the HTML and CSS and whatnot, they started finding restrictions or limitations to that technology. Right? It says, okay, well, HTML is only it's static, right? It doesn't maintain any state, right? So that's a big limitation. So they were looking, well, what do we do? How do we expand on those possibilities? If I want to create a weather application, well, it can't be static, right? If weather changes every minute. So how do I make it render dynamically, right? That as the temperature changes and the wind changes and whatnot, I want to show that information. So there's a lot of solutions. Early solutions were based on server-side solutions that the HTML, instead of being rendered statically from an HTML ASCII file, they were instead looking for mechanisms of computing the same HTML, but on the fly, as opposed to being a static ASCII file, right? So there was a lot of formats that were invented. The first ones were based on C++, Perl, that were running on the server, so that when you asked for content, you weren't asking now for just plain old HTML. You were now hitting an endpoint that executed on the server, right? Kicked off some execution on the server. The server calculated the HTML string, and a huge HTML string, and then streamed that back to the client as a dynamic HTML content, right? So now instead of looking your weather static. Now it would be dynamic over time. Every time you hit it, right, it would calculate a new HTML content. This became a very popular solution. PHP representing the peak of this strategy, right, became very popular format of creating of embedding executable content, along with HTML, along with CSS that was generated dynamically, became very popular. PHP, Java 2, the Enterprise Edition came along and took all those ideas and said, well, okay, let's do this idea, but now for the enterprise. We're now tackling not just small little pages here. We're tackling applications for the enterprise, right? For large applications, large databases. And so they came up with a lot of design patterns that became popular as it progressed. They introduced the idea of model view controller, introduced the idea of singleton patterns, data access objects, view objects, all these design patterns that eventually, became very mature and are making their way into client-side development, right? That are still with us today. Inversion of control, all these ideas were started by J2EE. .NET expanded on that idea and created their own set of design patterns. All sorts of many different server-side solutions became very popular during this decade. Starting with PHP and today, Ruby, Django, and Node.js, becoming also very popular. JavaScript, seems that it's embedding and it's like a virus. It's taking over the world. So Node.js allows us to execute JavaScript on the server side, the server solution as well. On the client side, also there were limitations as commercial solutions expanded and when they found limitations on the current technology, they looked for solutions around this, right? So one of the limitations that they had is that, again, HTML is static, right? A couple of things, and I don't want to bother the server with a couple of things. If I'm filling out a form, it's very awkward to submit a form that has errors, right? And hit a server with bad data, and then the server coming back to me saying, "Hey, the data is no good, right? Try again." So some of the solutions were to allow browsers to have and execute code on the browser, right? To do maybe some validation, validate the form before actually submitting it to the server, right? Make sure that the data is right and the age is correct and the numbers and the whatnot, right? And once the JavaScript could validate the content of the form, it could then successfully submit it to a server for processing. This became very popular. Adobe took a different approach to this and says, okay, I understand what we want to do is create some dynamic content, not necessarily on the server, but on the client, right? But they took a kind of like a take-all solution, right? They created an entire framework that took over the entire page, right? That created an entire user interface for creating very dynamic web interfaces. It eventually died out once Steve Jobs said that it would not support it on Safari anymore, and that was that. That was it for Adobe. Many other frameworks also evolved over this period. In particular, jQuery became extremely popular and still is very popular today, especially because there was a lot of war between the different vendors of browsers, right? Microsoft felt threatened that now the main way that folks interacted or bought a computer was to interact through the web, right? Through the interface of this browser, which rendered the operating system kind of meaningless, right? If all you're going to do is just browse the web, then who cares what the operating system is, right? And if all the applications are kind of migrating to the web, then there's no point of you buying desktop applications to install on a particular operating system. So it felt threatened that its dominance in the operating system space and word processing and whatnot, it was felt that if everything moves to the web, it was kind of lose out on many of its hegemony. So this created a fractioning of the browsers, right? There were certain things that were supported on Chrome, but were not supported on IE or in Safari or all the different vendors, right? On Firefox. And so jQuery kind of solved this on saying, oh, well, we'll create a layer of abstraction, right? That, instead of having you to create your code so that it can run on any browser, instead you code to a jQuery. We'll handle all the translation down below for you, right? So you don't have to bother with any of that, right? You just code to jQuery, which is kind of like what Java did, right? The idea of Java was to make the operating system irrelevant as long as you code it in Java. So jQuery tried to do the same thing. As long as you code in jQuery, the browser is irrelevant, right? So it created this layer of abstraction. It became very, very popular. Again, as we progress, applications on the client side start becoming more and more complex and more complex and more complex. Google in 2010 comes out with a solution to this complexity. Says, hey, we have all these design patterns that work really, really well on the server side that Java invented. The .NET worked on that and expanded and became very, very popular. They're very mature, all these techniques, to deal with complexity. How about we copy some of those strategies, right, and apply them on the client side for coding on the browser, right? And so they came up with Angular, right, that implements a lot of the design patterns such as model view controller, singletons, services, factories, and all these design patterns are very common in software engineering. It was very, very popular. It had a spectacular run up until they made a huge blunder when they went to version 2. In version 2, they kind of threw away, everything that they had built on, many industry that had gone the Angular 1.0 version all the way to version 1.6. When they went to version 2, nothing was compatible. Nothing was forward compatible or backwards compatible. So a lot of the industries, starting to reevaluate what other frameworks might be available. There says, well, if I'm going to have to, all the code that I've written, I have no path to migrate it into the new version 2. I kind of have to start all over. All the millions of dollars that I've spent, building all this code base, I kind of have to kind of throw it away. If I'm going to throw it away, well, I might as well just look and consider at other vendors. And that's where React, that had been lagging for a bit, had a really, really big opportunity to take advantage of that time space where industry were considering different versions or different alternatives, and it really took off. React.js is perhaps today it's the most popular front end framework today. Okay, so anyway, we'll both look at both of them. I think between React, Angular, and Vue are the three most popular frameworks today. If we have time, the last week or so, we can take a look at Vue as well, which is starting to catch on, a lot of traction. So it's a really good place to take a look at where we might be going. So here's just a map of a really, really high level of the things that we're going to be building this semester. It's the client server architecture, and see where things might fall. All the client side frameworks that we will be looking at, React, jQuery, Angular, they all fall on this side, right, on the client side. This represents the browser, right? A client is just anything that might be running on your local machine and might be making HTTP or network connections to interact with some server out there, retrieving data from a remote source and then rendering it locally on your desktop. Yes. So we're interested in a particular client, which is the browser, right? In a browser, we're going to be coding using JavaScript and HTML and CSS. We'll code client applications that run on the browser, right? Executing your JavaScript. Yes. These client applications, they're not going to have a place to store anything, although they could store. Theoretically, they could store stuff in the local file system through a couple of APIs, but for the most part, they won't have a place to store anything, right? They're running inside of a box, right, in a walled garden, right? And they have no access to the file system. They have the only thing that they can retrieve data from is from outside sources, right? The data source is going to be a server that is going to be running on some remote machine, right? And that remote machine is going to be referred to, we're going to refer to it as the middle tier, right? The middle tier is going to take incoming requests from the client, right? It's going to process those requests, whether it can serve those requests right away from the server. You know, if it's static content like HTML and CSS and JavaScript, if it's just looking for ASCII files, the server will probably be able to resolve that right away, right? It says it'll look in the local file system, look up the particular file that you're looking for, and it will spit it back to the client for rendering. Yes, but it will also not only serve for that, it will also serve requests for data, right? So sometimes the request will be for content, and sometimes the request will be for data. Okay, if it's for content, HTML, CSS, whatnot, the server will handle that right here on the server side, you know, and spitting back the that document, or it will ask for data. For data, it'll typically use a database to go fetch data, right? It'll make a network connection to a remote server, database server. In our first case, it'll be, you know, our first half of the semester will be MySQL. The second half of the semester will be Mongo. Okay, and then retrieve data from the database, come back to the server. The server, the first half of the semester will be a Java server. The second half of the semester will be Node, right? And then process, you know, pre-process that data that comes back from the database, and then spit back that data back to the client, typically formatted in the format of JSON, you know, JavaScript object notation, right? And then the framework here running on your browser. The first half of the semester will be React. The second half of the semester will be Angular, right? Two frameworks, right? And then we'll use that data to then dynamically update the front end and display the results to the user for consumption. Make sense? Right? So, you know, we always come back to this map and see where we are, right? The first 2-3 weeks, we're going to be spending it here. Almost the first 4 weeks, right? When we do HTML, CSS, React, Redux, right? All that, we're going to be spending it just only here. Then on week 5, we'll introduce the middle tier using Java, RESTful services and whatnot. And then week 7 or 8, we'll introduce the database, to talk to the database through using Java, JPA, and ORMs and whatnot. Yes? Now, there's two strategies for rendering dynamic content, right? The first strategy is what I described earlier, was that you know, the user would go out to a browser, ask for a web page, ask for if we're asking for a static HTML page, the server would say, okay, well, here's the file, the HTML file that you're looking for, send it back, and it's just rendered, right, as a static HTML page. Yes. You know, this evolved over time so that we wanted to have dynamic HTML. Yes. So what folks came up with, the idea is that, okay, well, let's create other HTML formats, right? Not just plain old HTML. We'll have other ones: JSPs, ASPs, PHPs, right? So these files, but with a different extension. Now, these different extensions, these files, didn't contain only HTML. It contained lots of HTML with some embedded source code embedded in there, with for loops and if statements and whatnot. Yes, switch statements in there. Depending on the language, PHP, you know, Java for JSPs, ASPs would be VBNet or one of those languages, right? And would have intermixed some HTML and some executable code. Yes, if you ask for those, the server would find the file, execute it here on the server, and it would generate a dynamic HTML string, a really long HTML string. Okay, it would rip out any source code, right? It would only leave the resulting HTML, and then it would stream the HTML back to the browser. The browser didn't know that this was dynamic, right? As far as the browser is concerned, this is a static content. It had no idea that it was dynamically generated on the server, right? But because what the browser gets is just static HTML. Yes, right? So this is where we spent, you know, about a decade using this strategy. It's still used, right? But it's now it's being abandoned a bit, and in favor of this new strategy. Okay, The new strategy is to instead of using server-side rendering, right, where you do the dynamic content on the server, instead of doing it on the server, is that we're moving a lot of the dynamic rendering to the client, right? The browser is going to be doing the logic for dynamically rendering the content. Yes, and it roughly works this way. You have the user asking for HTML content and JavaScript. It goes to the server, right, asking for this HTML. Right, the HTML goes back, and the JavaScript is downloaded from the server, right, and then from the browser's point of view, the request is static. You're asking for static HTML and static JavaScript. I'm not executing anything on the server, right? I am just sending you ASCII files. Yes, I don't execute any of these on the server. When it gets to the client runs the JavaScript, right? And the Java and the execution of the JavaScript will dynamically render the page, the content of the page. Yes, right. It will. Now, sometimes, or most of the times, the client side is going to need some data, right? And you imagine this is a weather application. Well, typically the JavaScript and the HTML that comes here is static. It has no information about the current weather, right? It needs data now, right? Not only do now I have a snippet HTML, I have some code, but I don't have any data. Typically, it will either go out to some third-party API, weather.com or whatever, right, and ask for the current weather, or it might go back to the original server and ask for data, right? And the server now, it'll before it had sent static HTML and static JavaScript. Now it's being asked for dynamic data. It says, hey, what temperature is it? How's the wind? What's the pressure? Right? It's asking for dynamic data. The dynamic data comes back to the browser with usually as a JSON string, right? The JavaScript parses that and it dynamically updates the content of the page. Make sense? Right, so this is how most modern web applications are implemented today, right? So anything from Google, from Facebook, Twitter, or anything, this big, Netflix, Amazon, they all use this new technology, right? Where it's mostly client-side rendering, right? Sometimes they will use a combination of both. This implementation is much faster, right? The server is going to be many times faster than any browser, right? Executing, it'll have threads, it have a multi-core, whatever, right? We'll have a lot of things pre-generated, right? A lot of content is already pre-generated, pre-calculated, right? It's so usually like a landing page, right? Or the first page that you see will probably use this strategy, right? We want to put content in your face as fast as possible. Right? We don't want to have you to wait, for the client to go fetch data, right? And then all these spinning things waiting to render, right? We want to put, a lot of marketing, a lot of things flashing and animation to catch your eye. Yes. So it'll be a combination of both, right? So for really fast rendering, maybe on the landing page, you'll have something like this. But then when you enter deeper into the application and you're doing some updating your cart or changing the quantity or whatever, right? Or the color, or I want to see a couple of videos and whatnot, they will use this kind of strategy, right? Where they fetch data on the back end, on the back side, right? And then they'll update the front end accordingly. Make sense? Okay.